And you're good.
Good afternoon, everyone. My name is Gary Ferguson, and today I'll be discussing how we create stage surfaces and cross sections without creating stage models. A little bit about myself. I graduated from Oregon State University in 2008. Upon graduation, I joined CH2M Hill, which is now Jacobs Engineering, and I've been there for about 13 years. So today, some of the learning objectives that we have, we're going to look into why stage surfaces are important and how they are used to create in Civil 3D. We're going to look at stage models, pros and cons. So I worked on a previous project on Highway 15, and we're going to look at some lessons learned about creating stage models on that project. We're going to look at some of the workflows for creating stage surfaces without stage models. We're going to look at some options for creating stage cross sections, and we're going to do that looking at with or without interim drainage considerations. And then throughout, we're going to look at the workflow for staged earthwork and how we merge all of that together. So, why do we need stage surfaces and stage cross sections? Well, there's a ton of reasons, but three that I've put here. One of them is to allow for accurate calculation of earthwork. So for instance, if we have a really large project and perhaps it's multiple stages, and over the course of that project, it's a pretty even balance between cut and fill. Well, that might be great, but what about the contractor's perspective where you have a stage one and you might have a massive borrow or a massive cut, and you're needing to reflect that for the contractor? Doing staged earthwork calculations is very important. It also allows for a visual check of the work zone and MOT relationship. What I mean by that is you need to see what's being built in a certain stage, and then where traffic's going to be running in relationship to that. Especially when it comes to the third point, which is facilitating drainage during construction. A lot of the larger projects that I work on tend to require some sort of interim drainage considerations. That, among all the other reasons that I didn't list here, are a good reason why we need to show our stage surfaces and our stage cross sections. So I'd like to cover a little bit of a project that I worked on recently. It's something that I got into about 60% of the design. And part of this project used staged models, and I'd like to go over some of the lessons learned for that. So the Highway 15 stage models. This is one of the projects that was actually requiring us to create staged models. This is a recent project out of Outagamie County. It's Highway 15. The existing is a 2-lane undivided highway, and we are expanding that to a 4-lane divided highway. And as you can see in the typical section, we had the 4 lanes. In general, 2 of the lanes were built on alignment over the top of the existing, and 2 lanes were built off to the side. And this varied throughout the project, but in general, half the project was westbound was over existing and eastbound was over existing in the other half. So we took a stage model approach, which required us to break up this full corridor that we had created with eastbound and westbound all in one corridor. We broke it into multiple models so that we could do a handful of things, including interim drainage. So our complete approach was we would have a full eastbound and westbound model through the 60% design. And then since the staging concept seemed pretty straightforward, we were going to break it up into an eastbound model and a westbound model. And then to that, we added median daylight links to model the interim drainage. So here's a stage section that we created. This is representing stage 1 of the Highway 15 project. As you can see, it copies and follows our typical section for the most part. I will point out there is one difference here where we normally would have the 10-to-1 coming to the eastbound subgrade shoulder point. We have this 4-to-1 here. And that was done for many reasons. One of the reasons was we had traffic running up on the existing roadway. And what we needed to do was we wanted to build as much of the westbound in stage 1 as we could, but then also make sure that, you know, we're not digging into the existing roadway. So we had to model this separately. So then you can see here in our stage 2 section, we have the line on the left here that represents the westbound stage 1, which we just showed you. And as you can see, here's our 10-to-1 stopping and the 4-to-1 from the previous model. And then our 10-to-1 came down to match, so that all in all, we had our total typical section built after the staged construction, but we also provided interim drainage. However, this became very difficult, this approach, for many reasons. One of them was the 60% models are never perfect, right? There's super elevation changes, there's drainage changes, there's profile changes. All of these affect the model. That if we had maintained one consistent westbound, eastbound combined model, it would be a pretty simple update. But once we broke these up into multiple models, the consistency became an issue. There were workflow problems. We had multiple DWGs where different models were located versus the one model DWG. And the main issue we ran into is the project became repackaged a couple of months before our 90% deliverable. And where we sort of logically broke up our eastbound and westbound for our staging concepts became less desirable. We had crossovers built in before that were no longer going to be used. We had to create new crossovers in different locations. All in all, the stage model that we used to break up logically became a little more difficult to work with. So here are some of the pros and cons that we found from the stage model approach. The pro was obvious. It's easy to create our stage surfaces, which help for our earthwork calculation. And in addition, we were able to easily grade for an interim drainage. This was great. It made our job a lot easier to make sure that the interim drainage was covered. However, some of the cons were our staging concept changed and the model became reflective of an old concept. In addition, we didn't really have these broken up into substages, and sometimes we were required to create earthwork for substages. So it became a little less flexible. We also found that the more corridors meant more data shortcuts, or in our instance, it was 2016 we were using, so we had to XREF the corridors, but it became a lot more data heavy. And one point I really want to make is the final surface that we provided was always a merged version of the stage surfaces. So we really never provided a complete top surface that was straight from a corridor with minor refinements. It was a merge of a refinement from stage 1 and a merge of refinement stage 2 and so on. And it became a little cumbersome. There were definitely some issues that happen when you start merging a lot of surfaces together. And I really want to point out that we found this approach prioritized the stage surfaces, but neglected the top surface. And the main task of modeling is to provide the best top and datum surface you can. So once we completed the Highway 15 project, we wanted to reflect on what we had done. We wanted to question why we use stage models, and we wanted to determine if there was a better way. So first, we questioned the need of stage models due to the issue we found with the lack of flexibility to change. Essentially, we found the only benefit to using stage models was the ease of creating stage surfaces and modeling the interim drainage. So we took a step back and we said, is there a more efficient way? Could we avoid splitting up our models, but still be able to create stage surfaces? And a bigger question is, do we need stage models at all? So I spoke to my construction management group at Jacobs, and it was clear that the contractor's not using the corridors. They're not using the stage corridors. What they are using is our stage surfaces that we're providing to create their automatic grading models. So if they're not using the staged corridors, they're using the stage surfaces. Is there a better way to create the stage surfaces, especially if it's not needed by the contractor? What we found is the stage corridors are just a tool to facilitate stage surface creation. And this was early in our Civil 3D knowledge, so we needed to question every assumption as we move forward. So now that we know that stage models aren't necessary, what can we do? Well, we can look at creating stage surfaces from a corridor model, from a complete model. What this does is it allows you to maintain a complete model and produce a final top and datum surface, which is the most accurate representation of the final product. In addition, it provides complete flexibility to recreate staging concepts as the project progresses. So let's look at how we create a stage corridor surface, and I'm going to go into Civil 3D. And I'm going to show you an existing current project that I'm working on. This is I-43 up in Ozaki County, and these are mainline corridors here. So this is my northbound corridor and my southbound corridor. And realistically, these can actually be modeled as one corridor, a combined combined southbound and northbound corridor, but currently, we have them separated. So what I found is an easy way to look at our corridors is actually to show them in cross-section versus going into section editor. So what I'm going to do is go ahead and create some cross-sections for this area. And I already have sample lines created. So I'm going to go in here and create our cross-sections. And here you can see we have our northbound and our southbound corridors here. So let's say, for instance, we needed to create a staging concept. So first of all, when we created this project, it seemed pretty simple. These are existing 2-lane southbound and 2-lane northbound. And we are expanding towards the median with an additional 3rd lane in each direction. So our original staging concept was a crossover south of this project. We would build all of southbound while traffic was on northbound. And then once that was completed, we would flip traffic and again, build northbound while traffic was on the completed southbound lanes. Unfortunately, this was a 30% concept, and as we dug into it more, it was determined that that was not feasible, and we started to look at other staging concepts. So what we landed on is an inside-out construction method, where we would build some of the inside lanes and shoulders while pushing traffic to the outside of the existing. And then, of course, we would come back with traffic on the inside and build the outside. So how do we create these staged surfaces to represent that? So I'm going to go over here and I'm going to draw a staging shape. Now this could be something that we have in a staging file that we could XREF in. But for the demonstration, I'm going to just go ahead and draw a staging shape. Now you can see here's my inside lane and shoulder with my barrier, and then my southbound barrier, shoulder, and inside lane. So I'm going to say we're going to build the inside lane and shoulder. So I'm going to go in here and just draw a generic staging shape here. And I'm going to go ahead and close that shape. And then just for a visualization, I'm going to hatch that. Sort of like we would a staging shape. Okay, So here we have a generic staging shape that would represent stage 1 of this project, where traffic's on the outside and we're constructing the inside. So how do we create those stage surfaces? Well, I'm going to go into my northbound corridor here. And here you can see that I have my top and my datum surface. So what I'm going to do is create a new corridor surface. Here's my top and datum. I'm going to call this stage 1 northbound. And I'm going to display this as some top triangles. Excuse me, I'm going to define this as top. Now, what I've found is the easiest way to create these surfaces is using links. Really, if you're good about your subassembly and the way you set your link type, this surface actually creates a very nice top surface and datum surface. So when I'm going to go in here and create a link-based top surface for stage 1, I will add that as break line. And I'm also going to create a stage 1 northbound datum. And again, I'm going to display these as datum triangles, bottom link overhang correction, and I'm going to add my datum links to this. Okay, so we have a top and datum surface directly in the corridor. Now all we need to do is add a boundary. Now, what we've done in other projects is the corridor shrink wrap. The limits of your corridor are the limits of your surface. But in this case, I'm going to add my surface boundary from a polygon. And I'm going to simply go down here to what we've created, select the polyline, and now you can see that that boundary is created from the polygon. And I'm going to do that again for the datum as well. Rebuild my corridor. And you can see now that we actually have a top and datum surface created from those shapes. So I'm going to go over here and show you how that looks in cross-section view. I'm going to go over here and sample more sources. And I'm going to bring in my northbound one, stage 1 top and datum. And what I'm going to do is to distinguish them, I'll just call them EBS for now, since that one sticks out a little bit more. And you can see now that we have a northbound top and datum surface to the limits of our edge line. So let's go ahead and do this for southbound as well. I'm going to go into my corridor properties and into surfaces and create 2 new surfaces. My stage 1 southbound top. Again, I'm going to make that top triangles. I'm going to overhang and I'm going to add top links as a break line. Then I'm also going to do this for stage 1 southbound datum. Show that as datum triangles, bottom link overhang correction, and I'm going to add my datum links as a break line. Okay, so now all we have to do is find our surfaces, add from polygon. I'll select the staging shape again. So we have these both defined by polygon. I'm going to build the corridor. And as this processes, we will be able to see that those triangles will now show up just for the area that we've defined on our polygon. Now this polygon, let's say for instance, we're working on the outside here. This polygon doesn't have to be tracing this exterior limit. It can be as far out as it needs to be. Because we're defining this by links, it's going to go out to the limit of the corridor, to the limit of this, even if the polygon's beyond it. It's not going to bring in any random data. Okay, so now you can see that this southbound also has been defined, and I'm gonna go over here and I'm gonna do the same thing again. I'm gonna sample more sources, and I'm gonna bring in the southbound stage 1 top and datum. And again, I will show these as EBS just to distinguish them. And now you can see that we have a very tight surface for both northbound and southbound. Now, the only problem is if these corridors, if I were to start these again at 30%, I probably would have combined northbound and southbound in one corridor. But since we didn't, we're going to create obviously two corridors are going to produce two separate surfaces. So what we need to do now is create a new surface that's going to just represent my stage 1 construction. And you can call this top and datum. I'm just going to create the datum surface for stage 1 at this point. The only reason you'd create a top surface for stage 1 is so that you can merge that top in with your existing surface to sort of represent your existing surface for stage 2, but we're not going to get into that today. So I'm just going to go stage 1 datum, say okay, and I'm going to add both stage 1 northbound datum and southbound datum. And I'm going to make sure that's been rebuilt. And then what I'm going to do is in these sample sources here, I'm going to remove the northbound and southbound separate. And I'm just going to go ahead and add the southbound 1 datum. And again, I'll show it as EBS just to show the difference. And say okay. And I'm going to remove the labels here. Okay. So again, now you can see that we have a merged stage 1 datum surface. So now that we have our stage surface, all we need to worry about now is calculating earthwork for stage 1. So if we go up here to analyze and compute materials, it's as simple as selecting your existing in the stage 1 datum that we've created. And we'll say okay. And now you can see it's calculated earthwork just for this portion of my corridor. Even though these are two separate corridors, I'm able to calculate and easily create these stage surfaces. Now, something I do like to do is if I go into my view properties, you can see the cut and embankment are shown in here in the same style. What I've done is actually made a copy of the WSDOT standard, and within here, I've actually change the fill color to red so we can distinguish between cut and fill. And there you go. So now we've easily created a corridor-based surface for stages, just simply based on our staging polygon shape. Now, the best part about this is it's pretty dynamic. So now that we've done this, let's say, for instance, now our staging concept has changed. And we don't have enough room, so what we need to do is actually build this northbound this second lane on northbound. So what I'm going to do is grab my polyline and I'm going to move this over to the second lane to represent the building of this second lane here. So now all I have to do is go back into my corridor properties. And what I'm going to do is, since it's just the northbound, I'm going to remove the boundaries for the northbound top and datum. Now the surfaces are still in here, they're still defined by links. All I'm going to do is just recreate the boundary based on the new shape that we have. Do that for the top. Go ahead and do that for the datum. Save, rebuild the core. And what you'll see as this processes is the new triangles, the limits will go over here for my northbound top. And now all I have to do is, since I didn't have this as a rebuild automatic, I'll rebuild my combined stage 1 surface. And then we can go over to the cross sections and see it's already been rebuilt. It's already recalculated the earthwork. because everything is dynamic in here. All we needed to do was delete that boundary, update our datum surface, and now everything represents us building these 2 lanes on northbound and this single lane on southbound. Okay, so now that we've created these stage surfaces from a complete model, let's look at something a little complicated that will build upon that. So what if the stage corridor surfaces aren't enough, right? You need to accommodate something like interim drainage, like the Highway 15 example, or let's say the profile is changing significantly enough that we're going to have a large fill area that we need to represent in the interim condition, because that's a lot of grading, that's a lot of earthwork. So unlike stage models, we're going to have to either use grading tools or a separate corridor to create the interim drainage. So let's look at that right now. Okay, I'm going to go to my other tab. So you can see again, we've got the same setup here. We have our stage 1 combined and it's calculating earthwork. But let's say, for instance, the traffic's over here, and what we need to do is actually create a ditch off of the completed lanes, just to make sure that whatever water is coming off of the completed lanes isn't going into the road. Or let's say, for instance, this road is sloped back to construction and we need to capture that water. So the easiest way I've found to create this is, first of all, let's find the limits of our stage construction on the edge here. And what I'm going to do is create an alignment along that edge. So here we have a stage 1 northbound drainage alignment. I'm going to start it at 10, and I'm going to say okay. And it's a simple condition where it's just a straight line in this case. And I'm going to say okay. Now, what I want to do is create a surface profile that represents the top of this pavement. And fortunately, I've got a complete top surface from my corridor since I haven't broken them up. So all I'm going to do is go over to Profile and create Surface Profile. I'm going to select my Stage 1 northbound drainage alignment. And I'm going to find my full corridor northbound top. And I'm going to add that as my surface profile, which is also going to represent my proposed profile in this case. And I'm going to say okay. So now I have an alignment and a profile that's along the edge of this staging line here. Now this is clearly something you should probably wait till final design to look at, because as staging concepts change, you're going to have to update this. But once things are relatively locked in, this is something easily done. So now I'm going to create a corridor that represents the edge of this. So I'm going to go over here and create a corridor, the Stage 1 northbound drainage. I'm going to use my Stage 1 alignment, and I only have the one profile in here. And I'm going to go over here and select this assembly that I've created. Now this is very simple. This is a 2-foot deep ditch with a link width and slope, and then a daylight link, and they're both at 3:1. So it's very easily created. Click on that. My target surface, of course, is going to be my existing in this case. And I'm going to say okay. And I'm going to create this corridor. And as you can see, we've got the corridor created over here. Now all we need to do is we can first sample that on the cross sections. So I'm going to sample my sources, and I'm going to add my Stage 1 northbound drainage. Say okay. So now you can see we easily created this daylight condition, this ditch condition, where we can now check to see how traffic interacts with that, and we can check drainage. But now we have to make sure that that earthwork, this portion of the earthwork, is captured in our Stage 1. So that's as simple as coming over to the corridor here. Go into corridor properties, and I'm going to create a corridor surface. And in this case, because it's just daylight links, you don't need a top and a datum because those are one and the same. So in this case, I'm just going to leave this generic. I'll display them as datum triangles. And I will create it as a top link. Okay, now all I need to do is add a boundary. And since the corridor extents represents what I want to create as a surface, I'll just add the corridor shrink wrap and rebuild the corridor. And you can see we have the surface created over here. Now all we need to do is paste this surface into our stage 1 datum that we've created to represent our stage 1 earthwork. So I'm going to go in here to definition. I'm going to paste my stage 1 northbound drainage surface, and I'm going to rebuild that. So if we go back over here, now you can see that it's automatically updating with the earthwork that's representative of our interim drainage. Okay. So now that we've looked at the interim drainage condition, we've been able to easily create a staged surface from the corridor without breaking up our model. And we've been able to dynamically change the limits of our construction in the surface that's calculating earthwork is automatically updated. So let's take it a step farther. Let's say everything you've done up to this point is perfect. And now what we need to do is make sure that everything that we produce in our final plans looks as good as possible. So if you looked at that section that I showed you before, we had the interim drainage, we had the corridor, everything was showing up nicely, except it might have been a little cluttered, right? It was on top of each other. Maybe you're doing the interim drainage as a check for yourself and just for earthwork purposes. You probably can stop here. But what if we want to show only the portions of the corridor that are actually being built in that stage, in addition to the interim drainage, and that's it? Well, we've developed a process that makes it easy for you to manipulate some sample lines and run with some dual sample lines so that we can show partial width construction, but not have a cross section that's partial width. So let's go back into Civil 3D, and we'll go into my final tab here. So let's say this is our final cross section. Again, it looks great, but it's a little cluttered in this area. It's maybe something where we would just quickly draw and place cells that just represented, stage 1 to the left, stage 2 to the right, and that's all you need. And that would be great. That's pretty detailed for most projects. But in other projects, some of these larger freeway projects, we can't just stop there. We need to show a little bit more detail. So what I'm going to do is cut a new set of sections over here. And what I've done is made a copy of the reference line here, and I've called this the sample line group exist. Okay, now I'm going to run through the process here a little bit slowly. So I've set this offset range to 160, 155. That would be automatic. But what I've also done is, instead of having the elevation range automatic, I've defined it. I've gone with a 50-foot height, which tends to be pretty good when you're building at grade. And I'm going to follow a section, and I'm going to select my southbound corridor for reference. Okay, and in this sample line group, I've got my 2 corridors, my stage 1 interim drainage, and my existing ground. I'm gonna go ahead and turn the labels off the existing. And what you can see in here is I have these styles set as existing ground for existing, but the two corridors, I have them displayed as no display. And we'll get into why that is in a little bit. So I'll create my cross-section group. There we go. So as you can see, it's basically the exact same look as we did up here, which was more done automatically. We have the existing surface. We have our interim drainage. But now what we need to do is show our proposed at a partial width. So I'm going to actually go ahead and just freeze this layer here to make things a little clearer to see. Actually, I'll do that after the fact. Okay, so what I'm going to do now is create another set of section views. Except in this case, I'm going to go to my sample line group, stage 1. This is again a direct copy of what I had done before with the sample lines, except what I've done, if you can see the faint purple lines over here, I've changed the width of those sample lines to only represent the proposed pavement that I want to build in stage 1. So again, I'm going to run through, and because of the variable width, it wants to change. I'm going to set this at negative 160, 155, just like before with the other sections. And I'm going to go in here and make sure that my user specified height is 50 again, and we're basing it off of the southbound corridor. And now again, I've got the exact same stuff sampled, except in this case, I've shown the existing surface as no display and the interim drainage as no display. And in this case, I've only have the southbound and northbound corridors displayed. Okay, so now I'm going to create cross sections and I'm going to snap to the exact same spot that I did before. And now I'm going to go ahead and freeze these so we can see what's going on in here. So what we've done is we've been able to modify sample lines. We've been able to manipulate them. So now we have a full width representation of the section for the existing surface and any sort of interim drainage. And then we've been able to modify these sample lines to only pick up what we wanted to pick up. So you can see here, again, here's the partial width sample line that we created. And now what this gives us is the ability to label these sections not as northbound or southbound, but this is stage 1 of mainline. And it represents exactly what the contractor has to build in stage 1. And we have a surface to pair with that top and datum. So now we're providing them all of the information and all of the tools to easily build partial width with interim drainage considerations. Now you can see over here, some of this text is overlapping. There's an easy way to fix that. So we don't really want the exist to show up. So if we go into view group properties and we go in here to our style of our section, I've actually created a new style that's called exist. And essentially all it does is turn off the graph title, but it just fixes that problem. And now we have, obviously this stage 1 is probably not what you'd call your sections for the reference line here. That's just specifically reading off of the alignment, off the sample group name. So you can manipulate this however you want, or you can manipulate how the description is read for each section. But in general, now you really have a clean setup that shows you what's being built with interim drainage considerations. Okay. Well, let's go back and summarize what we've looked at. So we've sort of looked at how stage models can be cumbersome and difficult to maintain consistency. And realistically, the stage models are breaking up your total product into multiple pieces that may be helpful to create interim drainage, but in general, it's giving you less flexibility overall. Maintaining a complete corridor is really what's preferred because it's going to provide you the best top and datum surfaces, which is really what we're trying to do, is provide the best top and datum surfaces. But it also makes things updating a ton simpler. So all you need to do is modify your border, your boundary of your surface, and you're easily able to update your stage surfaces once you define them. They can easily be created for various staging concepts. So if we want to look at how interim drainage is going to affect MOT, we can look at multiple different options very quickly, very easily. And we can easily manipulate sample lines to show partial width construction that represents our stage surfaces and represents the portion of the corridor that's actually being built in each stage. So I want to give a special thanks to Scott Wendt and all of my Jacobs colleagues who helped me with the development of these workflows. It's very much appreciated, and I'm happy to have such a great team helping me out. So with that, are there any questions?